Today I would like to share with you a tool that I've been working on. It's an online tool that helps you deal with calculations involving complex numbers. This should help you with your setting calculations and make fault records interpretation easier. This interface is available on my website, and you'll find the link in the description below. What you have here is the ability to manipulate the phasor with your mouse, and you can see that all resulting phasors on the other planes update in real time. You also have the option to manually input data in Cartesian form, as you can see on the left, or in polar form with a magnitude and angle. For example, if we take VA in polar form, at the moment it's at -42. If I switch it to +42, you'll see that the values update. You can adjust phasors either through the inputs or by dragging the phasors directly. It's completely bidirectional. Here, you have a series of pre-calculated values. For example, you'll see the impedances for a phase, B phase, and C phase, as well as the 0, positive, and negative phase sequence impedances displayed here on this graph. Below that, you'll see phase-to-phase voltages, phase-to-phase currents, and phase-to-phase impedances. There's also ZT, which is the summation of the positive, negative, and 0 sequence impedances, and ZN, which is often used in setting studies. These values are calculated based on the voltages and currents, rather than coming directly from the transmission line crew that provides these values. This allows you to calculate impedances from the measured voltages and currents. Imagine you receive fault records from the field after a fault. You have voltages and currents, and you can use this tool to calculate Z1, Z2, and Z0. You can then correlate and compare these calculated values with the ones provided by the transmission line design engineers. For interest purposes, I also added admittances, and I did the same for apparent power. You'll see the apparent power for a phase, B phase, and C phase, along with the 0 sequence, positive sequence, and negative sequence apparent powers. These values are not typically used in relay applications, but I thought it would be interesting. It made me think, why not use these values of 0 sequence and negative sequence apparent power in differential protection schemes? For line differential protection, we traditionally rely on current, but perhaps incorporating apparent power, which depends on both voltage and current, could bring more stability or advantages, especially given the increasing impact of renewables on the grid. That's something to think about, and it might be worth exploring for R&D engineers. One feature I hope to add is the ability to export these values for further analysis, for example, in MATLAB. These are real-time values, and you can switch from phasor or vectorial representations to numerical values. All values are updated automatically, with both polar and Cartesian forms available for flexibility. If you want to get a closer look at the graphs, you can simply double-click to zoom in and drag the graph for a better view. Double-click again to return to the default view. This feature works across all graphs, and as you change values, you'll see how the apparent power values also update. I'm also thinking of implementing load balance simulations, where you can drag a voltage with equal amplitudes and angles, and see how the values interact. Another potential feature is fault scenario simulations, which could be a valuable tool for setting studies and fault record analysis. You can delete or restore elements of the interface using the button on the left. The input field can be dragged and repositioned, and there's an information button that provides more details about the graphs. There's also a light mode and dark mode for better visibility, depending on your environment. Let me know what you think, what you'd like to see added, or what could be improved in this tool. It's freely available online. Just register on my website to access it. I'd love to hear your feedback.